Our next speaker is Charles Nesbitt. He's Exploration Manager for Core Energy, speaking on targeting critical minerals, uranium and rare earth element exploration on the Eyre Peninsula. Thank you, Charles.
G'day everybody, great to be here again at the SAEMC conference. It's a highlight for me at least every year. Unfortunately I get a year older every time it comes around. If we can work out how to go around for that, that'd be great. But I'm here to tell you today about Core Energy Minerals. Core Energy Minerals is a junior exploration company, head office based in Perth and exploration office based in Adelaide. We're pulling together a portfolio of high quality assets in Tier 1 mining exploration jurisdictions around the globe. We have projects in Brazil where we have a first mover advantage in the uranium space. The INB, which is the Nuclear Bureau in Brazil, that currently controls all the uranium assets within the country, have indicated that they're now making moves to open up that industry. And being in the right place at the right time, we've managed to secure a number of uranium assets within that country. Also, whilst that regulatory process goes through the motions, we've also acquired a number of rare earth assets which we'll be pushing pretty hard over the coming months. So Namibia, Tier 1 uranium jurisdiction. We have, it's a world-class uranium producer, and we're in amongst that, planning on heading out there early next year to start to kick off exploration and progress those projects. But what I'm here to tell you about today is our South Australian assets, which is also another Tier 1 uranium jurisdiction with bipartisan support and strong regulatory systems that are in place and tried and tested, with a number of world-class uranium deposits, and it's well truly tested. So our projects in South Australia range from are mainly centred around the Eyre Peninsula, but also up in the central Gawler Craton with up in the Harris Greenstone Belt. What we like about the Eyre Peninsula is that it has all those elements that are required for uranium mineralisation. We have an abundance of uranium deposits or occurrences within the area. We have the source rocks. We have those hydrological systems that transport the uranium from those source rocks into the trap sites, which are the reduced paleo channels. So all those ingredients are there, and the existing mineral occurrences are proof of concept. So this is a bit of a close-up of our Eyre Peninsula projects, which consists of our Cummins, Brooker and Western Eyre projects. And as you can see, those Moody Sweet granites are also thought to be a source for uranium, or strongly associated with uranium in the area. And the radiometrics show those Copio Hills running up the east coast of the Eyre Peninsula, and the Marble Range running up the west coast. Their elevated topography driving those fluids down into the paleo channels within the Cummins and the Brooker, particularly, and then those Moody Sweet granites as a topographical basement high, draining and towards the south. So our Cummins project. So what do we like about the Cummins project? It's got all those elements for the mineralising model, and previous exploration from the likes of Eyre back in 2009 to 2011 have done broad-scale regional exploration and shown anomalous uranium within those paleochannel systems, which are correlatable across kilometres wide drill holes over 10 kilometres. So that's proof of the mineralising model. It shows those systems are active, it shows those trap sites are active, and that's what attracted us to this project. We just recently completed a 27 air core drill hole program in July. 27 holes, 2,700 metres approximately, across 6 prospect areas, mainly in the north of the project area. This is the rain sort of hampered us somewhat to test some of those targets to the south, but yeah, that's okay. We're okay with that. There's plenty of uranium sitting in the northern areas that we could test. We were constrained by drilling alongside the road just for ease of access for that primary initial program. But we've confirmed the mineralisation within the paleochannels and got a 4 metres over 100 ppm hit within the Peninsula formation, and also got some elevated mineralisation in the basement as well. So now all of a sudden there's multiple deposit styles that we'll actually be targeting. Mineralisation sounds a little low grade to the lay person, but that is an excellent start for regional exploration. One thing these paleochannel hosted deposits have in common is broad scale, low grade mineralisation, and now it's a matter of understanding those systems, the source, transport, trap systems, to target those high grade zones of mineralisation. Here's a couple of cross sections of our 2 most significant hits within our project, and within the Peninsula formation, CAC 0007, we got a significant hit, 4 metres over 100 ppm, and as you can see, that mineralisation clings to the margin of that paleochannel, which is another attribute commonly seen across these paleochannel hosted uranium deposits. And then down our Mari Road project area, we have these little thin significant hits down in the weathered basement clays, and we think that might be vein related. There's a number of uranium occurrences within the general area that show these vein-related style mineralisation in basement rocks. So that's quite interesting in itself. So what can we do from here, right? So we've confirmed mineralisation, broad, low-grade mineralisation, but what this tells us is it gives us some vectors to work towards in targeting that high-grade mineralisation. So understanding that the higher grade stuff sits in the paleochannels along those channel margins, now we need to target those paleochannel margins. Source rocks. So here's an image of the northern areas and the radiometric image, the uranium channel. And that shows, also we have the Moody Sweet granite polygons from the SAEMC database. So what this shows us is the radiometric response is quite high around these Moody Sweet granites, and we've got some radiometric anomalies on the margins of this granite. We've got some of the highest radiometric anomaly in the state geophysics within the entire state, right? So this is comparable to the anomalism that sits up in the Mount Painter region, Mount G area, Radium Ridge. So so the Moody Sweet granites are either a source or strongly related to the uranium source. Now, looking at the gravity, we have very poor gravity coverage over our Cummins and Brooker project areas. However, we have 1 kilometre space grid sitting just to the north of that project area. And that gravity grid sits over our Moody Sweet granite plutons, which we think is related to the source uranium, or one of the sources of uranium, and it shows these drainage channels draining off of those Moody Sweet granites. So what we our targeting methodology is looking closer to source. One thing I forgot to mention in the cross-section slide is we never found many significant intersections in the drilling that we did within the Upper Peninsula formation. So let me just go back quickly. Sure. The Upper Peninsula formation is a very organic rich unit, and as the Lower Peninsula still reduced but less organic rich. We get very little significant mineralisation in that Upper Peninsula formation, and we believe that is because it's such a strong reductant. All the uranium is being trapped closer to the source. So therefore, when we're looking at the drainage lines into these paleo channels, we want to target those confluence points where those drainage channels hit that main reduced paleo channel. That'll be our main target areas. So our Western Eyre project, we've had this large tenement holding for some years now. There's a whole swag of occurrences and mineral deposits over there: iron, diamonds, base metals, kaolinite, and so forth. We did a big drill hole database review, looking at end of hole lithologies, and discovered that there's a whole swag of alkaline intrusives and pegmatite intrusives within the basement rocks. So looking at the rare earth side of things, we sampled some of those alkaline intrusives, in particular Hill 55 and Conical Hill, sent them off for assay and got significant rare earth results. Subsequently, the leach testing wasn't that encouraging. However, rather than going back to the drawing board, we just amend the model now to think, right, well, we've got source rocks. We've got rare earth element source rocks. How do we find those trap systems? Well, luckily for us, other examples within the region are having some good success with identifying rare earth accumulations within these paleo channel systems. So we've got paleo channel systems present within our tenement package. We've got the source rocks, so now we're going to embark on a review of these rare earth potential within these sediments. And lastly, our project is Central Gawler Craton, which is a Harris Greenstone belt. Sits in the Yellowbinna Regional Reserve. There's very little drilling. There's just a handful of drill holes in this entire tenement package of 1,300 square kilometres. The last company to have it was Vale Australia, who have subsequently pulled out of Australia. They were looking for nickel and copper, but what they left us with was a first-class geophysical data set and a native title NTMA with the Far West Coast Aboriginal Corporation. So with this highly defined paleo channel system from the VTEM, and as you can see, the hashed line areas is Hill to Pursuit granites, which is a known source for within South Australia for uranium mineralisation, and we have a number of prospects and occurrences of uranium within these paleo channel systems. And then that kind of proof of concept again that that uranium is leaching from these granites and into these paleo channels. Together with the excellent work that Bao Hong's been leading up on the paleo channel investigation in that area, we look forward to start testing some of these target areas which have never been before tested. So that's my talk. We've got some excellent news flow coming up across not only South Australia but Brazil and Namibia, and I guess the message we sort of leave you with is we have those systems in place for the next uranium discovery. We've got the source, we've got those transport systems, and we've got those proven trap systems. So now we just need to find those high-grade target areas. Thank you very much.